Hello, Algebra 2 students, and welcome back to another lesson. This is 7.4 on logarithmic functions. So we've spent the last two sections dealing with exponential functions. Now we're going to move on to the inverse of the exponential function, which is called the logarithmic function. All right. Now, if you remember from 7.1, we discussed inverse functions. So the log function of base b, which is written y equals log base b of x, and that's what that b is called. It's called the base. It's written as a subscript of the log. So again, we say log base b of x. It's the inverse of the exponential function y equals b to the x. So the log base b and the exponential base b are inverses of each other. So again, think back to 7.1. Uh, what happens to any point on the graph when you find an inverse? Well, if you remember, if a function takes you from input to output, the inverse takes you backwards from the output to the input. So on the point, any point on the graph, x and y switch positions. The input becomes the output. So once again, on the when you take the inverse of a graph, the x and the y switch positions. So we're going to start by graphing the log function based on graphing the exponential function, which you already know from 7.2, and graphing its inverse. Okay, so let's review. You learned this in 7.2. The graph of y equals b to the x. Let's assume b is bigger than 1, so we have exponential growth. All right. Remember, there was 3 points I had you learn. The y-intercept was 1, and there was a horizontal asymptote at y equals 0, and exponential growth looked like this, right? And the other points were 1b, and then -1 reciprocal of b, right? So again, that was a exponential function for b bigger than 1. The 3 points were -1, 1 for b, 0, 1, and 1b. There's a horizontal asymptote at y equals 0. And the domain was all real numbers, and the range was 0 to infinity. Okay, so now let's graph the inverse of that. Let's graph y equals log base b of x. That is the inverse of that function. So what are we going to do? As we said right here, we're going to take every point on the graph, the x and y switch positions. Okay, so instead of having a y-intercept of 1, the log function has an x-intercept of 1. And instead of having a horizontal asymptote at y equals 0, it has a vertical asymptote at x equals 0. All right. And instead of going through the point 1b, it's going to go through the point b comma 1. So it's going to look like that. It's going to look like that. And then if you want to do a third point, instead of -1, 1 over b, it's at 1 over b, -1, but I'm not going to draw that one. Don't worry about that. As long as you know these 2 points and the asymptote, that's good enough. So where the exponential function increases very quickly, the log function increases very slowly. You can see as it's increasing here. It almost looks like it's flattening out, but it's not. Be careful. This graph does not have a horizontal asymptote, even though it looks like it might. It does not have a horizontal asymptote. It just grows very, very, very slowly. So if you remember, because the x and y switch, the domain and range switch. So the domain here is the range here and vice versa. So the domain here is 0 to infinity, and the range here is all real numbers. Okay, so that's important to know. When you have a log, the input must be a positive number. Let me say it one more time. When you have a logarithm, the input, the x, must be a positive number. You cannot take the log of 0. You cannot take the log of a negative number. Okay, so first thing we're going to do is we're going to practice rewriting between exponential form and logarithmic form, changing between exponential logarithms, all right? And we're going to be doing this very, very frequently when we deal with logs, going back and forth from exponentials to logs. So what I'm about to write right here is probably the most important thing you can know about logs. Everything we're going to do after this is going to kind of come back to this. So if you know how to switch between a logarithm and an exponential function, then you're doing pretty good. So y equals log base b of x. Now that's a logarithm. Let's write it in exponential form. So remember, the log and exponential function are inverses. So when you switch from log to exponential, the input and the output switch. The y here becomes the x, and the x becomes the y position. So what does that mean? Here, y is the output and x is the input. In the exponential, then, x is the output and y is the input. So what does that mean? Y equals log base b of x is equivalent to x equals b to the y. So y equals log base b of x is equivalent to x equals b to the y. Or another way of saying is that this base to this exponent equals that number. That's what you're doing when you're answering a log. You're saying, what is the exponent? What exponent on b gives me x? B to the y equals x. So kind of keep that in mind. When you're answering a logarithm, the number you're giving is an exponent. What exponent on this base gives me that number? Okay, so right now we're just going to practice going back and forth with this, switching between log form and exponential form, and vice versa. So example 1, write each equation in exponential form. So I'm giving you 3 logarithms. I want you to write it as an exponential function uh, or exponential equation. So we're basically just going to go left to right. We're going to take this and write it like this. So when you look at this, say what's the base, what's the y, and the x in this case. So the base is 3, the y is y, and the x is 7. So in exponential form, that's going to say that 7 equals 3 to the y. 3 to the y equals 7. So one more time, this base to this exponent equals this number. Here we go. Log base 5 of w equals 2. So 5 to the 2 equals w. W equals 5 to the second. And then last one, log base a of 1 over 20 equals 4. So a to the 4 equals 1 over 20. 1 over 20 equals a to the 4. All right, so that's writing an exponential equation, or sorry, writing a log equation in exponential form. Now let's flip it around, go backwards. I'm going to give you an exponential equation. I want you to write it as a logarithm. So now we're going right to left. We're going right to left. We're going to say log base b of this number equals this. Log base b of this equals this. So in this case, log base 4 of 30 equals c. So let me write that down. C equals log base 4 of 30. And notice when you write a logarithm, again, the 4 is a base. You make it smaller. You make it a subscript on the log. Log base 4 of 30. Okay, now, and let me just kind of explain to you how to say that, because this is your first experience with logarithms. We say log base 4 of 30, right? It's not a product. Don't say log times 30. That's what students like to say, log base 4 times 30. This is not a product. It's a function. Log base 4 of 30 equals c. All right, next one. Log base 2 of x equals negative 7. So negative 7 equals log base 2 of x. And lastly, log base m of 33 equals 5. So 5 equals log base m of 33. So I'm going to give you some practice over this. I want you to become really familiar with going both directions, left to right, right to left. You have to go both ways. Convert from a log to exponential function, an exponential equation back to a log equation. Okay, now, next page. There are 2 special kinds of logarithms that you're going to see. Okay, and if you look on your calculator, a scientific calculator, a graphing calculator, any calculator, you'll see both of these: a common log and a natural log. Okay, um, those are 2 special kinds of logs. Okay, the common log is just written log of x. That's a log base 10. Okay, so it's just written like a log without a base. So if you ever see log of x with no base, the base is 10. Okay, so if you see log of x, if you see a log with no base, that means the base is 10. It's called it's called the common logarithm. The natural logarithm has a base e. If you remember, we mentioned this number previously, talking about exponential functions. E is an irrational number, so it's a number that goes on forever without repeating, like pi. E is an irrational number, and we use it so often that we give its log a special name. It is the natural logarithm, okay, which is the ln of x. ln of x. Okay, so you'll never see log base e of x written. You'll never see that. If you see ln of x, that means natural logarithm. If you're wondering why we use ln, it's because it comes from Latin, logarithmus naturalis or something like that. So anyways, ln of x, if you see that, that's log base e. Log of x is log base 10. Okay, you'll see those two on your calculator. We'll use those down the road. Okay, so back to this. This is what we did previously. Write each equation in exponential form. Okay, and you may want to write on the top of your page one more time. Y equals log base b of x is equivalent to x equals b to the y. Okay, so that's what we're doing here, only we're using the two special logs, common log and natural log. So this one, when you see a log without a base, just know that's base 10. So what does that mean? 10 to the third equals 1,000. 1,000 equals 10 to the third, which of course is a true statement, right? Next one, ln of 22 equals m. So when you see ln, that means the base is e. Write it with the base of e. So e to the m equals 22. 22 equals e to the m. All right, so we're going to stop there. This will be your first homework assignment I'm going to give you. Okay, is going to be over this. All right, next video we'll get to evaluating logarithms. But for now, I want you to just practice writing logarithms and switching between log form and exponential form. Okay, so your first homework assignment is going to be in the problems that I post on Google Classroom here, 7.4 homework copied from the textbook. I want you to do all the even problems on this page. So 2 through 34 even, okay? So may seem like a lot of problems, but they should go very quickly. All you're doing is just rewriting from one form to another. This section's in log form, write it in exponential form. This section's in exponential form, convert it to a log form. So there's nothing to solve, just write it from one form to the other. So again, the even problems, 2 through 34 even. That is your first assignment, and then check back for a second video continuing 7.4.